Probability for equally likely outcomes. A bag contains 20 discs marked with the whole numbers from 1 to 20 inclusive. Part 1. If one disc is picked at random from the bag, find the probability that the number on the disc is divisible by 3. We must identify the experiment and the sample space. Then we calculate n. Moving on to the event, we calculate or. At that stage, we can write down the probability. So the experiment is to pick a disc. S is the number from 1 to 20. So S being the sample space. So the number in the sample space is 20. We have 20 options in total. The event is to pick a disc which is divisible by 3. And from 1 to 20, those options are 3, 6, 9, 12, 15 and 18. Each of these numbers are divisible by 3. And there are 1, 2, 3, 4, 5, 6 of them. So or is equal to the cardinal number of E, which is 6. Then the probability of E happening is or over n, which is 6 over 20, which simplifies to 3 over 10. So we got this formula from here, or representing the number of favourable outcomes, or basically what we want, divided by n, representing the total number of possible outcomes. So the probability is 3 over 10. Part 2. If 2 discs are picked at random from the bag, what is the probability of getting one even number disc and one odd number disc? So we need to choose 2, one odd, one even. The experiment here is different. Choose any 2 from different numbers. It is not practical to list the outcomes in S, the sample space, but we can count them using the NCR formula from chapter 21. The event E is more complicated. We want to choose 1 from 10 even numbers and 1 from 10 odd numbers. Remember, and means multiply. We can then use the fundamental principle of counting to calculate or. So the experiment is to choose 2 from 20 numbers. So n, which is the amount of elements in the sample space, is going to be 20, choose 2, which is really 20 multiplied by 19, divided by 2 multiplied by 1, which is 190. The event is choose 1 from 10 even numbers and choose 1 from 10 odd numbers. So or is going to be 10 choose 1 and multiplied by 10 choose 1. 10 choose 1 is 10, and 10 choose 1 is 10, and 10 times 10 is 100. So or is 100. So then the probability of E happening is or divided by n, which is going to be 100 over 190, which simplifies to 10 over 19. So the or, again, being the number of favourable outcomes, or basically what we want, and the n being the total number of possible outcomes. A bag contains 4 red, 3 blue, and 5 white markers. 3 markers are drawn at random from those in the bag. Brian bets that all 3 markers will be of different colours, while Katie bets that all 3 markers will be the same colour. Determine who has the greater probability of winning. So the first thing we have to do is add up the 4, the 3 and the 5, and that gets us 12 markers in total. First, we must identify the experiment and count the number of outcomes in the sample space. The experiment is to choose any 3 from all 12 markers. So the experiment is choose 3 from 12 markers, or you could say 12 choose 3. So n is the number of elements in the sample space, which is 12 choose 3, which is the same thing as 12 times 11 times 10 divided by 3 by 2 by 1, which is 220. So let's have a look at Brian. The event E is getting 1 marker of each colour i.e. 1 red and 1 blue and 1 white. The fundamental principle of counting may be used to find OR. So we have to choose 1 from 4 red and 1 from 3 blue and 1 from 5 white. So OR is the number of elements of E, the cardinal number of elements. So we have 1 from 4 red, which is really 4, choose 1, and, which means multiply, 3, choose 1, and, which is multiply, 5, choose 1. 4 choose 1 is 4, 3 choose 1 is 3, 5 choose 1 is 5. So 4 by 3 by 5, which is 60. So OR is 60. Then the probability of E, the event, is OR divided by N, which is 60 divided by 220, which simplifies to 3 over 11. Remember OR is the number of favourable outcomes, and N is the total number of possible outcomes. So now let's have a look at Katie. Remember that the experiment was choose 3 from 12 markers, and that N, which is the cardinal number of elements of S, is 12, choose 3, which is 220. So having a look at Katie. The event E is getting 3 markers of the same colour. We can break this down to either 3 red or 3 blue or 3 white. So remember, OR means add in probability. The second fundamental principle of counting can then be used to calculate OR. So the event E is choose 3 from 4 red or 3 from 3 blue or 3 from 5 white. So OR equals the cardinal number of elements of E, so the amount of favourable outcomes. So we have 4 choose 3, or, which is plus, 3 choose 3, or, which is plus, 5 choose 3. That gives us 4 plus 1 plus 10, which is 15. So OR is 15. Then the probability of E, the event, is OR divided by N, which is 15 over 220, which is 3 over 44. Remember, the OR is the number of favourable outcomes. The N is the total number of possible outcomes. Thus, Brian has a greater probability of winning. 2 dice are thrown. What is the probability that we get a total, which is a prime number? So, it's very important to know what a prime number is. A number that can only be divided by itself in 1, only has 2 factors. And also to know that in order to get a total, we're going to have to add. So, for example, if I roll a die, and I land on 5, and I roll another, and I land on 1, the total is 5 plus 1, which is 6, and so on. So 6 obviously is not a prime number, but if I was to roll a die and land on 5, and roll another and land on 2, 5 plus 2 is 7, which is a prime number. When 2 dice are thrown, we can get any number from 1 to 6 on the first die, and any number from 1 to 6 on the second die. These can be laid out in the form of a table as shown below. The outcomes belonging to the event can then be indicated by dots or other marks. So if I roll a first die, I have the options of 1, 2, 3, 4, 5 and 6. And if I roll the second die, I have the options of 1, 2, 3, 4, 5 and 6. So for example, this square here represents that I landed on 1 on the first throw and 2 on the second throw. This square here indicates I landed on 3 on the first throw and 6 on the second throw. So the experiment is to throw 2 dice. If we use the notation 3, 5 to stand for getting a 3 on the first die and a 5 on the second die, then S, the sample space, is 1, 1, 1, 2, ... 6, 5, 6, 6. Thus, N, the number of elements in the sample space, is going to be 6 times 6, which is 36. So there are 36 possible outcomes. Event E is that I get a prime total, i.e. a total of 1, 3, 5, 7 or 11. These are my only options. The table below shows which outcomes give a prime total. So for example, this dot here represents 6 plus 1, which is 7, which is a prime number. This dot here represents 5 plus 2, again, which is 7, which is a prime number. So all of these add up to 7. This dot here represents 6 plus 5, which is 11, which is a prime number. Both of these add to 11. This dot here represents 4 plus 1, which is 5, which is a prime number. All of these add to 5. This dot here represents 2 plus 1, which is 3, which is also a prime number. So these both add up to 3 prime numbers. And this dot here represents 1 plus 1, which is 2, which is also a prime number. So our formula for the probability of the event happening is the number of favourable outcomes divided by the total number of possible outcomes. So we know the total number of possible outcomes is 36, and the total number of favourable outcomes are basically all our dots. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So it's going to be 15 divided by 36, which is 5 over 12. So the probability that we get a total, which is a prime number, when 2 dice are thrown, is 5 over 12.